Hey everyone, and welcome to today's Explainer. So if you've been following the AI space even a little bit lately, you've absolutely heard the acronym RAG thrown around. It's literally everywhere, usually wrapped up in a whole lot of hype. Well, today we're going to cut right through all that noise. We're diving in to make one of the most fundamentally important architectures in modern generative AI completely understandable. We're not just going to give you a dictionary definition. We're going to open up the hood, look at the engine, and show you exactly why RAG has become the absolute powerhouse of enterprise AI. Let's get into it.
But first, to really grasp why Retrieval-Augmented Generation, or RAG, is such a massive game changer, we have to talk about the villain of our story. Look, we all know large language models are incredibly powerful, right? But they have a fatal flaw. They hallucinate. They will confidently just make things up out of thin air. And why is that? It's because traditional LLMs are trapped. They rely solely on their initial training data. If that data is outdated, incomplete, or simply doesn't contain your company's deeply private internal information, the model literally has to guess. RAG was built to completely eliminate this exact problem.
Okay, here is our quick roadmap for the explainer today. We'll start with the AI knowledge problem, then compare RAG to fine-tuning. After that, we'll look at the power of data chunking, dive inside the actual retrieval process, compare basic versus advanced retrieval, and finally, take a peek at the future of RAG. All right, part one, the AI knowledge problem. Let's look at the huge divide between the old way and the new way. On one hand, a traditional LLM only knows what it was trained on, which could be months or even years ago. It has zero access to the live world, meaning the risk of it hallucinating is inherently super high. But a RAG system, it's a completely different animal. It dynamically accesses external knowledge in real time. Basically, it connects the incredible reasoning power of the AI with the exact, up-to-the-minute facts of your specific enterprise. This drastically lowers those hallucination risks and makes updating your AI's knowledge incredibly cheap and easy. Moving on to part two, RAG versus fine-tuning. So when you need to teach your AI something completely new, you basically have two options. And as enterprise architects, it is absolutely crucial that we understand the difference here. Think of RAG as giving the AI an open book exam. You aren't permanently rewiring the AI's brain, you're literally just handing it the perfect textbook right before it answers a question. It uses external data on the fly, it's super easy to update by just swapping out the textbook, and it costs next to nothing. Fine-tuning, though, that is like sending the AI back to school for months. You are going in and fundamentally modifying the model's internal weights. Now, fine-tuning is amazing if you want to completely overhaul the AI's behavior, its tone, or its writing style, but it is incredibly expensive, highly complex, and honestly just a terrible way to teach an AI new facts. Which brings us to part three, the power of data chunking. So, if RAG is an open book exam, how exactly do we organize that book so the AI can read it in milliseconds? I mean, you can't just drop a massive 1,000-page PDF onto the AI's desk and expect instant answers. This is where a critical concept called chunking comes in. Because of token limits and processing constraints, we simply can't feed an entire database or a giant 500-page HR manual into an LLM all at once. Instead, we use document loaders to extract the raw text, and then we strategically slice that text down into much smaller, highly focused chunks. This step is a make-or-break moment for retrieval accuracy. If you mess up your chunking, your AI is going to pull totally irrelevant information. The big question is how we divide this data. The industry best practice right now is aiming for about 300 to 1,000 tokens per chunk. But listen to this, because here is the real secret sauce. You have to overlap those chunks. Imagine reading a really good book, and the page ends right in the middle of a crucial sentence. If you don't overlap your data chunks, the AI loses the context of the thought right at the boundary. By purposely overlapping them and keeping semantically meaningful boundaries, like cutting at paragraph breaks, we perfectly preserve the context. We ensure the AI never misses the middle of a vital idea. Section 4. Inside the retrieval process. Let's actually trace the hero's journey of a single user query as it travels through this pipeline. But before we could even search through those chunks we just made, the text has to be translated into a language that computers natively understand, which is numbers. We use an embedding model to convert our text chunks into numerical vectors. I want you to think of this vector space as a gigantic, multi-dimensional 3D library. But in this library, books aren't organized alphabetically by author, they are organized by meaning. Concepts that are semantically similar physically live right next to each other in this 3D space, which makes finding them lightning fast. Okay, here is the whole architecture playing out step by step. Step 1, the user asks a question. Step 2, we use that embedding model we just talked about to convert the user's question into its own vector. Step 3, we dive into a specialized vector database, like a Pinecone or FAISS or ChromaDB, and we run a similarity search to find the document chunks that live physically closest to the user's question vector. Step 4, we pull those top most relevant chunks. And then we hit step 5. This is the big one, prompt augmentation. This happens right before the final response is generated in step 6. Step 5 really is the absolute magic trick of the whole RAG system. Prompt augmentation is where everything seamlessly comes together, totally invisible to the user. Behind the scenes, this system builds this master prompt. First, we give the AI a very strict system instruction, like, hey, answer using only the provided context. Then, we paste in those top relevant chunks we just pulled from the database. And finally, we tack on the user's original query at the very end. We hand this entire package to the LLM. The model isn't trying to remember anything from its original training, it's literally just reading the exact, verified context you handed it and producing a perfectly grounded, factual answer. Part 5. Basic versus Advanced Retrieval. Now, getting that basic pipeline up and running is a huge win. But if you want true enterprise-grade accuracy, where mistakes are simply not an option, you have to level up. Basic retrieval just relies on that semantic similarity search we walked through. But let's be real, sometimes you don't want a similar idea. Sometimes you need an exact keyword match, like a super specific part number or a customer's user ID. That's where advanced RAG comes in. Using hybrid search, it beautifully combines exact keyword matching with semantic meaning. But wait, it gets better. These advanced pipelines also use re-ranking models. So after the vector database pulls the initial batch of results, a second incredibly smart model scores and re-ranks those specific chunks. This ensures absolutely nothing but the highest quality, most pinpoint accurate documents make the final cut before being sent to the AI. Finally, Section 6, the future of RAG. As we wrap up this explainer, let's zoom out a bit. Where is this foundational architecture actually heading next? Because this tech is moving at lightning speed. RAG is rapidly evolving way beyond simple question and answer chatbots. We are heading straight into agentic RAG, where autonomous AI agents can actually decide for themselves when they need to go fetch information and actively use external tools to do it. We're also seeing huge leaps in multi-hop retrieval and graph RAG. These use knowledge graphs for highly complex connected reasoning. Basically, the AI can dynamically connect the dots across dozens of different, completely separate documents in your enterprise in real time, rather than just pulling one isolated fact. It's truly wild stuff. So I want to leave you with this final thought to chew on. RAG has completely shifted the AI paradigm. It is the bridge covering that massive gap between static, frozen AI memory and dynamic, real-time factual truth. So when we live in a world where AI systems can securely and dynamically research literally any piece of enterprise data in milliseconds with zero hallucinations, how will that transform the way you and your team interact with information tomorrow? Thanks so much for joining me for this explainer. Keep exploring, and I'll see you next time.